This little video is going to go over solving a system of linear equations, and it's just going to be two equations with two unknowns, and I'm going to solve it 4 different ways for you. So, the 4 different ways we'll talk about are the addition slash elimination method, substitution. We're going to use an augmented matrix to turn it into the reduced echelon form, and then we will also do Cramer's rule. So let's start with the addition method, and I'm going to use the same equation all the way through, or a set of equations actually. So I have x plus 2y is 8, and I have 3x minus 2y is 8. So the addition method says, hey, I want to be able to add these together and make something disappear, and hey, look at it. I have positive 2y, negative 2y, so if I just go ahead and add those, I see that the y's disappear. Awesome. So now I have x plus 3x is 4x, 8 and 8 is 16. So my idea with the addition method, which we also call elimination, is that I eliminated one of the variables. Y is gone, which makes it really easy for me to solve for x. So dividing by 4, now I know x is 4. Okay, so there's halfway. I need to figure out what y is, so all I need to do is plug that x value back in, and you can put it into either one of the equations. I'd say I'm a little bit lazy, so I'm always going to pick whichever looks easier for me, and I think that first one looks easy because I don't have to multiply the x by anything. So I put 4 in. I have 4 plus 2y is 8. Push that 4 over to the right, so now I have 2y is 4. Divide by 2, and y is 2. That's my answer. Because what I'm looking at here is 2 lines. They're just not written as y equals, but these are 2 lines. They're going to intersect at a point, and the point they intersect at is 4, 2. So this is my solution. So it's important to notice that my solution set is a point. It's not just 4, 2. I want to put them together and recognize that they are associated that way. Right, so we are going to do this same set of equations, but a totally different method this time. This is called substitution. So the idea with substitution is I want to solve for one of these variables, either x or y. I don't care. But again, I told you, I'm a little bit on the lazy side. So the lazy part of me says, look at that x. X is all by itself. It's not a 2y, it's not a 3x, it's not a negative 2y. It's just hanging out. So because it's just hanging out by itself, I think that's my prime candidate for what I should solve for. And you can see right here, I just pushed this 2y over. Now I have x is negative 2y plus 8. I'm ready to do substitution. So I take this x equals negative 2y plus 8, and I'm going to plop it into this equation here. So now I have 3 times negative 2y plus 8 minus 2y is 8. Do you see why this is called substitution? I took this value and I subbed it in here, and now this lets me solve. So this I can distribute the 3. I have negative 6y plus 24 minus 2y is 8. Push that 24 over, put the negative 6y, negative 2y together. I have negative 8y is negative 16, so I'm almost done with this part. I get y is 2. Awesome. Now let's see if we can solve for x. When we solve for x, we already have an easy way to do it. We have this equation that we came up with, right, that we started our substitution with, negative 2y plus 8. So that's where I want to put this 2. So I have x is negative 2 times 2 plus 8, and this gives me negative 4 plus 8, so I got 4. Not a surprise, right? We did this on the last slide too, but it just shows you that using the substitution method also gave us the solution for 2 that we were looking for. Okay. Another method, augmented matrix slash RREF. Actually, I'm just going to do REF. We're not doing RR, but whatever. All right. Step 1 is to write the equations as an augmented matrix. Pretty much that just says, hey, get rid of all those variables and just stick with what numbers do I have. So I'm just grabbing the coefficients. So you can see there was a 1 here, so I have a 1. 2 is here, 8 is here. Next row, here's my 3, here's my negative 2, here's my 8. This line just separates. Like, think of it as this is where my equals was. It goes right there. Okay, so step 1 done. Now, what do we want to do? The idea with the REF is I want the diagonals to be 1s and anything underneath it to be a 0. That'll really help us solve. So check off. We're kind of in good shape because we already have a 1 right here. That's awesome. So what do I want to do now? I would like to make that 3 go away. So here's, I wrote it for you formally. The A11, which is this first one, first row, first column, is a 1. I want to make this 3 go away. I need it to be a 0. So I think, well, how can I make 3 go away? What if I add negative 3? 3 and negative 3 is 0. So this is the additive inverse. If you want to get technical here, I just want to add the opposite. The things I'm allowed to do, I can switch rows, I can multiply a row by any non-zero number, and I can replace a row with a multiple of the row plus another number, right? I get to do a little bit of fancy stuff. So here I think, well, if I multiply this 1 by negative 3, it would become negative 3, and then negative 3 and 3 would be 0. So that's my plan. I'm going to replace the second row with negative 3 times row 1 plus row 2. And let's really write that out so we can see what that's going to be. So here's my negative 3. 1 times negative 3, 2 times negative 3, 8 times negative 3. We just have to be consistent. First row remains unchanged. The second row, negative 3 and 3 is 0. Negative 6 plus negative 2 is negative 8. Negative 24 plus 8 is negative 16. So second step accomplished. I have made this 0. Right. What did I say my goal was? My goal is to have 1s on the diagonal. So I have a 1 here. I have a 0 here. Good. Now I want to make this a 1. This is a little easier. All I need to do is divide by negative 8. So this is what I'm telling you I'm going to do. I'm going to replace the second row with negative 1/8 of row 2. Easy enough done. 1, 2, 8 stays the same. I divide by negative 8. I divide by negative 8. That's 1. I divide by negative 8. That's 2. Multiplying by negative 1/8, divided by negative 8, same thing. It's just a matter of how I said it. I'm not trying to confuse anybody. All right, so now what do I have? Well, it shows that this y is 2. This was my x value. This is my y. This is, what do I get? So this says 0x plus 1y is 2, so y is 2. Awesome. Now I know the value of y. Once I know that, I can plug that back into my previous equation I had, this one up here. So I'm going to plug the 2 in. I have x plus 2 times 2 is 8. That says x plus 4 is 8. X is 4. Once again, we got the same answer. That's awesome. So we're doing the different ways. This one feels like completely different, but we're always getting the same thing. So the last of the 4 methods I'm going to show you in this really short little video is Cramer's rule, which I think is really fun. So Cramer's rule feels like a little bit like a matrix. So here we have to start by finding determinant. So the first determinant I do just comes from these values. So the 1 from the x, the 2 from the y, the 3, and the negative 2. So I have 1, 3, 2, negative 2. And to take the determinant, remember we're going to go diagonal, subtract, diagonal. So 1 times negative 2 minus 2 times 3. Okay, let's simplify that. Negative 2 minus 6 is negative 8. So that's our d. That's our first determinant. Now we want to do d sub x. So what's happening? Instead of having these coefficients that came from the x's, I'm going to replace it with these numbers here. So 8 and 8. So x gone, 8 and 8 comes in, and I do this new determinant. So 8 times negative 2 minus 2 times 8. Once again, I simplify. So this says I have negative 16 minus 16, which is negative 32. Now let's do dy. Same idea with dy. This original y's are gone, and I plug in these 8s. So here, I have 1, 3 right here, and 8, 8 here. I go across. 1 times 8 minus 8 times 3. Okay, this is 8 minus 24, which is negative 16. So I've done my determinants. We have d, we have dx, we have dy. Now we're ready for the answer. So to get the answer, I'm going to start with x. I take my value of dx, and then I divide it by d. So I have negative 32 over negative 8. Big surprise, it's 4. All right, same thing for y. I take dy, which we said was negative 16. I divide it by the d, which is negative 8, and we get 2. So that's awesome. Again, we got the same thing. We got the 4, 2, and we can see there are a multitude of ways to get there. I will put something together where these get a little harder, but I wanted you to have one basic one you could look at where it was kind of hopefully easy to follow the steps.